Rational equations. So now what we're going to be doing is we're going to be solving equations that are all in fractional form. And in order for us to solve fractional form equations, the easiest way to do that is to eliminate the fractions. I don't mean by taking them outside and shooting them. I mean by multiplying by common denominators to let them just simplify out. This is a very easy skill to do. For example, I start with something like this, where I have x over 3 plus the x over 4 equaling 7/4. And what I want to be able to do is I want to get rid of my denominators. And in order to do that, I'm going to multiply both sides of the equation by that common denominator. Yesterday you couldn't do that because you did not have an equal sign. When you have an equal sign, you're able to keep things balanced on both sides because remember, numbers are jealous. What you do to one side, you have to do to the other. Okay? So what's going to be the common denominator of a 3 and a 4? 12. So what I'm going to do here is multiply this out the long way a couple of times, and then I'm just going to start shortcutting it. So if I multiply both sides of this equation, basically distributing a 12 to everything, you will be pleasantly surprised to see what happens. You get 12x over 3 plus 12x over 4 equals 12 times 7 over 4. No, because when you're multiplying fractions, you're always just multiplying numerator straight across. So now, are each one of those individual parts monomials?
Yes.
All right, what's 12 divided by 3?
4.
What's 12 divided by 4?
3.
I'll move it up. What's 12 divided by 4? 3 times 7? What do you get?
Now that is
using the common denominator to multiply out on both sides of this equation, it allows the denominators to go away and gives you a more workable problem.
I'm guessing not all of them are going to be this easy.
No, of course not.
Are we going to go on 2-term, 4-term, or
Oh yeah, we'll go. Well, you still have to be able to go on a factor and do all that, but it's the process there is still identical. And the only reason that this works is because you have an equal sign. Since you're maintaining the equality to both sides, you're multiplying 12 to one side, multiplying 12 to the other, it allows it to work. Okay. Same idea here. I've been telling people throughout the day today, when you're writing down problems, especially when you get to your homework today, you know how you have that little red strip on one side? You guys usually start, oh, here's number 2, and you write the problem right next to it. Move it over, a couple inches. All right. The reason why I'm saying that is because today you're going to be multiplying so much by common denominators, it's easier to have a little bit of space here to write that part out as opposed to it being right here and you're writing it into the ledger. Does that make sense? Just trying to give you guys a little
life hack.
life hack, yes. All right. So let's see, we have x over 3 minus x plus 2 all over 5 equals 2 over.
1.
So again, what's going to be my common denominator?
15.
15. So I'm going to multiply everything by 15. I'm going to go the long way again. I have 15x over 3 minus 15 times the quantity x plus 2 over 5 equals 15 times 2. Do I have 3 monomials again? Can I simplify all of them independently? Okay. 5x minus 3 times the quantity x plus 2 equals 30. I don't see any fractions anymore.
Down there again.
I don't know. It's one of those things. Just hang out in the vanities. Distribute and solve. 5x minus 3x minus 6 is 30. You get 18. Nice, easy work. The only thing that you're going to screw up here is you're going to forget that when you distributed a negative, negative 3 times positive 2 is negative 6, not positive 6. That's usually what you mess up.
So wouldn't it be easier if we just, when we were like multiplying the whole thing by 15, wouldn't it be just easier to multiply x plus 2 by 15 and then?
There's no reason to. There's no reason to, because if you do that, you're still going to have to simplify out by dividing all those parts by 5. Don't do it. The whole idea of multiplying everything by that 15 is so that these fractions drop out and you get 3 and 5. That's the whole point.
If we don't, but there's a chance that we forget to distribute the negative.
You're just going to take a lot more space. Seriously. Trust me on this. Okay? Do that one. So if you multiply everything by 3, you get 9x plus x.
Equals 15.
Is it okay that I don't show the distributive property in the simplification of that one fraction?
Yes.
Okay. You get 3 halves?
Yes, I did.
Is it 17?
I did that right. I was scared. I did something that right when I tried.
All right. What's going to change in the process then when we start putting in more variables and stuff?
Darn.
That's okay. I don't know.
3 over 2. 15 divided by 10 is 3. One thing I will suggest right off the bat in these types of problems. Don't cry, no. Look at where they put the negative symbol. It's kind of right next to the fraction bar. Put your negative to the number in the numerator. It's a little bit easier to work with, okay? Put the negative to the number in the numerator. Your book tends to write it this way, and I don't know why. I mean, it means the same thing, but...
Magician.
Remember, I have had a smartboard for about 7 years.
Okay, wait. You'll go through all of that to get rid of it, but then you'll just draw the symbol back in the top. That seems a little weak to me.
You just switch it, cut and paste it up to the top.
You got skills. No, that won't cut it. That won't cut it.
There you go.
It's a 78 degree angle, so to the perpendicular.
It's not the
to
right
L
line.
in the number 1.
What is he even talking
I
about?
don't know. I was trying to make
It's a little too long.
Are you cold?
No?
Is anybody cold?
No. It's 80 degrees.
Go sit in the corner. It's 90 degrees.
That's like a good thing to use. Like it's a 6th grade math.
For someone who keeps their room extremely freezing.
It's just using the fun.
Yeah.
What's the common denominator?
Oh, wait.
Yeah, you're trying to slow. Shut up.
What's the common denominator, guys?
2x.
2x. So if I multiply everything by 2x, I'm going to start showing you how you shortcut writing out the extra steps. First fraction has an x in the denominator, so do I need to worry about multiplying it by an x?
No.
No, all I have to do is multiply it by the 2. Second fraction has the 2 already, but it needs the, so it's 5x. Last fraction has the x already, it needs the 2. Subtract the 8. Get 6. Now, if you went ahead and distributed out the common denominator to everything, it's just an extra step. What I'm saying here is eventually it should become a little bit easier to start to shortcut it some. There's nothing wrong with that. Okay? Now, also what you can do. Oh. The other thing, yeah. No, it's not over 2x. Since what we're doing here is we're eliminating the denominators. And just like we did in the other ones, when I multiplied everything out by the 15, it's simplified out to getting rid of the fractions. What we're doing here without showing that step, this is 2x times 4 over x. The x's go away.
Yeah, so it was 8x over x and you got rid of the x.
Correct. So we're just skipping that. You don't have to if you don't want to. I am. Yeah, I run on 8. Now, one of the things you can do with your calculators and stuff is you can still check your answers to make sure that you were right. So if you wanted to go to your calculator and our fractions were, what was it, 4 over x plus 5 over 2, we said the x value was -6. So alpha y equals, enter, 4 over -6 plus alpha y equals 5 over 2. And when I add those together to check my answer, it gives me 11 over 6. You agree? Yep. Now, if I'm looking at this, it's supposed to be -11 over x. But what is x? So is -11 over -6 equal to this?
Yeah.
Then it's okay. All right? Then it's okay. Because sometimes you could get an answer that looks like it's an answer, but it's not an answer.
What do you mean with measuring?
This class is fake.
Look at
This
this.
can't be a real thing.
It is a real thing.
If we're gonna find so many imaginary or unreal things, then this class can't be real. It's just an illusion. I'm convinced I nap in this class.
Paying no attention to the man behind the curtain.
There's no curtain in here.
Well, then don't pay attention.
There's only blinds.
So-
There's no man behind the blind.
In this one here, we have 5x over x. Ooh.
I thought
We have
more.
5x over x minus 2 equals 7 plus the 10 over x minus 2.
7 over 1.
Yeah, 7 over 1. So what's going to be our common denominator here? X minus 2. So I'm going to multiply everything on here by x minus 2. You guys see what I'm saying by moving that over a little bit? You've got some room to work on the left-hand side. Does that make sense why I was suggesting that? Yeah. So first fraction, it has an x minus 2, so do I have to do anything? No, so I have 5x. Second fraction, it needs it, doesn't it? Yeah. So it's 7 times the quantity, x minus 2.
So basically those cancel out.
Yeah. We're simplifying it instead of writing it down. Okay.
I have a question. Alright, so since it's, why is it 5x? Why is it just, oh wait, never mind. Was it,
That was a great conversation. I am glad we were all part of it. So we get 5x equals 7x minus 14 plus 10. X equals 2. Good. Subtract 5x, add 4. It's the same answer. You forgot the negative. What's 5 minus 7? Negative 2. Then what's negative 14 plus 10? That's why we tend to move the negatives around. Now, guys, hold on now. We said that the value of x here is 2, but look at your problem. Can x equal 2?
No.
Why can't x equal 2?
Because then it's 0.
Can you divide by a denominator? Can you divide by a denominator? Yes, you can divide by a denominator, but can you divide by 0?
No, the calculator gives you an error.
Like 7.
So this is an answer, but it's not an answer.
Stop.
Negative x.
So this is what you call an extraneous solution. Sure. Phony. I like that. It's a phony solution. Extraneous. I think that's how you spell it.
Yeah.
Extraneous solution. It's a solution, but it's not a solution.
So what is the solution?
You can write no solution, it's okay. In this case, it's very rare that you have an extraneous solution when your variables are in the numerator. You don't want to, more often than not, you're going to wind up with an extraneous solution when your value becomes 0 in the denominator. There are times that you can get it where you might not have an equivalent statement. This could equal 1/2, this might equal 3/4 if you did everything right. Then it could still be extraneous, but it's usually because it's a 0 in the denominator. All right?
So when those two cancel out, does it become 1 and 0?
What?
Are you saying that when those two cancel out, they don't become 1 and 0?
Guys! Please, one last time for.
Are you saying that the x minus 2, the 2 that cancel out, doesn't make it 1 or 0?
Well, what's 2 minus 2?
0.
That's fine. Because if you substitute this back in, you're going to get divided by 0. You can't do that with that. So that's why we call it extraneous. It's a solution, but it's not a solution. It's like the meaning of life. Well, there's a reason, but yet it's not the reason.
So if it comes up on a test, do we just write the?
Extraneous solution.
Okay.
Sir.
Is there like any way to come up with a number that would fit there, like I or something like that, imaginary? No. There's nothing.
So, let's try one that you have to do a little bit of factoring with.
Why the test just by x equals 2 with that 2 wrong?
It is because it doesn't work. You have to write, doesn't work or extraneous or
Phony.
phony. I like that phony. It's not a bad. It's a good one, Hopworth. I'll give you that.
Yes.
So, sorry, let me write this out first. Process doesn't change when you have to worry about factoring denominators. You're still going to try to figure out where your common is, so that way you can multiply it through and get rid of them. Hopefully, yes, sir.
Can things cancel out across the equal sign?
No, because look at what's happening. You got to tack down 3.
Oh, that's addition.
Okay. Now, you're thinking, all right, try to jump ahead and go cross multiply. Remember, you can only cross multiply if it's fraction equal fraction. This one I have fraction equal fraction plus something. Can't do it. Now, does everybody agree that my common denominators can be x plus 1, x minus 1?
Yes.
We're okay with that?
Yes.
So if I write that out, first fraction needs a what? Needs an x minus 1. So it becomes 4x plus 1, x minus 1, equals. The second fraction, the 12 over the x squared minus 1, does it need anything? No. But the last one needs them both. But instead of writing x plus 1, x minus 1, I'm going to go back and write x squared minus 1. And the reason I'm doing that is because I'm going to have to distribute it out anyway. Might as well save a step. Okay? Because we know x plus 1, x minus 1 is x squared minus 1. So now you wind up distributing, combining like terms on both sides of the equation. We get 4x squared minus 4x plus x, so it's minus 3x minus 1 is, well, this is 3x squared minus 3, so it's 3x squared plus 9. We okay on that? Now we set aside equal to 0 to get a solution.
And how does it,
What's 12 minus 3?
uh,
So now you want to set aside equal to 0. What side do you want to move? The right side or the left?
Right side.
Move the right side because on the left side you have a higher integer value for your coefficient that's positive. So you want to deal with positives. We're happy people. So you have x squared minus 3x minus 10. Very good.
I read the book.
What are your zeros?
5.
Wait to check.
Yeah. Check your zeros then. You can see the denominator is right up top here. I'm not going to get a 0 in the denominator for either one of them, am I?
They're both right.
So go for it. Okay.
So they're Yes.
No.
The opposite of an X is an N.
No.
So it's a Y. Or it.
This is the last one I have for you.
That means it.
Oh, then it's an N.
Last one I have for you here. We have 2 over x squared minus 1 equals 1 over x minus 1.
it's x squared minus squared minus x.
Oh, sorry, I said minus 1. Yeah, x squared minus x, excuse me. Now, in this case, it's something looks a little bit different than what we've been working with. This is fraction equal fraction, isn't it?
Yes.
Whenever you have fraction equal fraction, what can you do? Okay? We okay with that? No, I'm just cross multiplying right now. It's not gonna be x because you can't subtract this. They don't have the same degrees.
But if you had like, oh,
So now we wind up with 2x minus 2, x squared minus x. Move it over to the right. What times what's 2? You add together, get negative 3. Do they both work? No, which one doesn't?
1.
One doesn't work.
So 1's a phony, 2 is a real.
What's that? You just cross it off. That's okay. You can, when you show that, you just cross off the one, because unless you just show that the one doesn't work, just by crossing it off if you want. And that's fine. I'm okay with that. Now, there is another way to do this. Could I have done this same exact problem via the common denominator?
Yeah.
If you go back and look at it, let me just move this over. If I go back and look at it, isn't my common denominator for this going to be x minus 1?
yeah.
So if I did that to both sides, this side has both of them, doesn't it? This side needed what?
The order cross multiply is still better.
That's
Superior to Y.
Sometimes it works. And by doing it that way, you alleviate the extraneous solution. It's just dumb luck, I believe, in this problem that it happened like that, but it does happen.
Can you redefine extraneous solution?
It's an answer that's an answer, but it's not an answer.
Well, it involves something with 0.
Hey, get out! If you substitute 1, it's an answer, but it doesn't work. You put
There
in
could
1.
be an asymptotic, but they're
What's
like,
1 squared? What's 1 minus 1?
0.
You divide by 0. See what I'm saying? It's an answer, but it's an answer that's not an answer. So they call it extraneous. It's a solution, but it's a solution that doesn't necessarily work. Okay? Let me give you a few of these to try out.
Throw pages.
She's sassy.
Oh, it's orange, so I'm gonna write it in orange. No, I'll write it in purple.
I like her, and the person, and then.
5 seconds. 52, 27 on.
Yeah. She
5,
was
7,
a lot, too.
85, 7.
Like, he was sitting on top of, like, he like gets in the corner, and he sits in
Am I right?
he'll sit in that corner.
27 on.
No, he's in the front corner, the front right corner.
I sit in the corner by the garbage can. I pull myself against the wall so I can and I don't let anyone be
Oh, see, he sits on the like, he sits on the.
We're getting there.
You're sitting on the
I was gonna say,
Do those, please.
You're wrong.